Alright, I've got something here that I never thought I would see again to repair, but here it is. Truffles. Just kidding. I got a APW8 power supply in for repair. It's kind of shocking. These things are getting pretty ancient. They came in the S15, T15, S11, and a couple other miners. There's a couple different variants, which if you watched any of my channel, you'd know. So let's go ahead and open this thing up. The customer said it wasn't outputting any power, which is dead. So go ahead, remove the screws. Man, I feel rusty, man. I haven't done one of these in quite some time now. I'm sure it'll come back to me. I do have like a whole binder full of parts for these though, so I've got parts for them. But these things still go for like 60 bucks, which is kind of crazy, being that the miners aren't really worth anything. But whatever. Back in the day, these things would go for like 200 bucks a pop. And that's why I could repair them, because there was some margin to fix them. Unlike the newer Bitcoin miners, these ones were worth fixing. So let me take a look around. Nothing obvious. Go ahead and remove these screws here. Now I know this one's discharged because it's been sitting for days without power. Come on. This silicone they put on the board is pretty terrible. Really makes things hard to remove sometimes. But whatever. That's Bitmain for you. Alright, so what you do is just bend this panel back a little bit so it's easier to get the board out, flip it over. First thing we're gonna do is check fuse. If I can kind of get this in the shot here. Let's see here, there we go. All right. This conformal coating they put on here is really thick. It's hard to get your probes down on it. I should be getting a connection here. All right, and then the fuse goes from here to over here. And oh, that's interesting. It says the fuse is not blown. I've actually not seen one of these where the fuse is not blown on it. Okay. If the fuse is not blown, then I'd imagine this rectifier is still good. Check that pin. That pin. Okay, well, oh boy, I just noticed something. You see that? This this resistor is definitely burnt right there. Let's go ahead and check this resistor down here. It's a common one to go bad. Okay, 1 ohm, that's good. This is saying 1 ohm, but I'm not sure if I believe it. Let me zoom out here so you can see. Yeah, that I'm going to go ahead and change to this resistor here. And see if that makes a difference. Okay. Not seeing anything right off the bat. Burned up our problem. So I'm gonna go ahead, plug this thing in, see if we can get fire out of it. Hopefully not, but it's happened lots of times before, so find out. Alright. Take my 220 plug here. So I like to plug this end in first. This end here. Okay. Plugged in, and we have no fans. Which is awesome. Charge the back connection. There we go. 240 volts. So we're getting 323 volts out of the rectifier. It's good. Volts on caps. it's fluctuating on the on the 6-pin here, which means we have a problem with this circuit down here. Let me go ahead and plug this. If you look closely here, you can see this trace almost looks burnt. See that? I have to still be careful here because it's still got high voltage in the rail. Turn this on resistant mode. Yeah, so we're getting good connection between those two. Alright, so false alarm on that one. It just looks burnt up to me. Guess it is not. So the next thing to do is dig away this silicone. Because under the silicone is a resistor that likes to go bad. So I'm going to go ahead and do that.
Alright, let's go ahead and check this resistor. And this is the one that brings the high voltage down to this chip and turns it on. That resistor is good, 47 ohms. Let's check this resistor. Get a contact here. That one's good. Let's check this. Let's check this resistor over here again. Alright, so that one's good. Let's go ahead and check these diodes. Flip the probes here. Alright, this diode's good. Ooh, that looks like a short. Let's go ahead and flip the probes. And yes, that is a short. Now, is the short coming from the diode? Let's find out. Go ahead and remove this diode. Alright. Let's go ahead and test it. See if it's the diode or if there's a different short on the board. Still a short. 0 voltage drop. Alright, so there's something shorting. What is it? Let's go ahead and put this diode back. There we go. Alright, let's go ahead and check this little cap here. That says it's short. Yep, 4 5 ohms. Yep, 5 ohms. Alright, let's go ahead and scroll down to the board view here and find the 12 volt 1. Alright, so here we have the 12 volt 1, and there are only 2 capacitors on this circuit. So we have C34, that's on the other side of the board, and we have C32. So let's go ahead and go down to the board view and find where C34 is. Okay, right here. Here's C34. So that's one we need to check. That's probably the one that's bad. And then we got C32 right here, right next to the diodes. So we're going to go ahead and remove C34 and see if that's the problem. Alright, here's the cap. Let's go ahead and test it. Get my multimeter right up here. Alright, let's test this. Alright, short is gone. So it was that cap. Let's go ahead and test that cap real quick. Yep. 5 ohms. That one was short.
Just realized that the capacitor, hold on, let me get this thing to focus. Right next to it is completely gone. Just the lags sticking out. Alright, let's get these lags removed from this other capacitor. Alright, let's see if we can pull these lags out. Perfect. Alright, so I'm going to go ahead and install this capacitor here. Trim those ends off. Off a little bit lower here. Don't accidentally touch anything. Okay. Now to find capacitor for that, because this one says this one is a 10 microfarad. All right, I've got the capacitor here I found. Let's go ahead and stick it in. This could be difficult. Have to pause real quick and put this in. Alright, got it in there now. The flux in there. Alright. Sorry, it's kind of hard to see with all that burnt junk there. Try to get it cleaned up a little bit here. That conformal coating is pretty terrible when it starts to burn. Really makes a mess. Alright, that's good enough for now. I'm gonna go ahead. So I'm gonna go ahead and plug it in. Go ahead and flip this over for you so you can see. Alright, here's the 2 caps I put in. Right there. Alright. Set this in there. Plug it in. go. Fans are so loud. I forgot how loud these fans are. One of the fans is not working. Might change those out for him. 12 volt output over here. 12 volt there. I'll check the main voltage here. You can jump these pins on this connector. Not that you can see. Got main voltage. Alright, if I fold this. There we go. So they glue these wires down in here. Make them awful hard. Get out. There we go. I mean, I get they don't want them to pop out in shipping. Go ahead and remove these fans. There you go. Successful repair on this APW8. I should say that right. Go ahead and put it back in its box of chocolate. Or truffles, that is. There we go. Ship it back to the customer. Thanks for watching. See you next time.